Hello dear friends, welcome my channels. Today's discussions limit theorem. So friends, let's start to discuss limit theorem. Theorem number 1, sandwich theorem. If Sn, Un and Tn be three sequence such that Sn less than equals to Un and Un less than equals to Tn for n belongs to n. And number 3, limit n tends to infinity Sn equals to L limit n tends to infinity Tn, then limit n tends to infinity Un equals to L. This theorem is called sandwich theorem. Friends, I do not give examples because examples is you can get a lot of examples from the book of real analysis. I just discuss this video on the sandwich theorem, but I will give examples in my next video when I will publish. Next, theorem 2. Theorem 2 is that Cauchy's first theorem. Cauchy's first theorem on limit n tends to infinity Sn equals to L. Then limit n tends to infinity S1 plus S2 plus S0 Sn equals to L. So this is the Cauchy's first limit theorem. Example: limit n tends to infinity 1 by 2 to the power half, 3 to the power half, n to the power half. So friends, here you see S1 equal to 1, S2 is equal to 2 to the power half. Similarly, Sn is equal to n to the power 1 by n. Now, we have to find out limit n tends to infinity n to the power 1 by n. So friends, this value is, this is Sn. Limit n tends to infinity Sn equals to n to the power 1 by n equals to 1. So according to the Cauchy's first theorem, limit n tends to infinity Sn equals to limit n tends to infinity S1 plus S2 plus Sn by n. So our first value is limit n tends to infinity n to the power 1 by n equals to limit n tends to infinity 1 plus 2 to the power half plus 3 to the power 1/3 plus up to n to the power 1 by n divided by n equals to 1. Next problem is Cauchy's second theorem on limit. Cauchy's second theorem on limit is that if Sn is a sequence such that Sn greater than 0 for all n and limit n tends to infinity Sn equals to L, then limit n tends to infinity, this value I have to find out. Now, for example, you see that limit n tends to infinity 2 by 1, 3 square by 4, 4 cube by 3 cube up to this way to the power 1 by n. So friends, whatever you see S1 is equal to 2 by 1, S2 is equal to 3 square by 2 square, S3 is equal to 4 cube by 3 cube up to Sn is equal to 1 plus 1 by n whole to the power n. So friends, Very simple. Limit n tends to infinity. Sn is equal to whatever we know. Limit n tends to infinity. S1, S2, the product from Sn whole to the power 1 by n. So whatever we see, limit n tends to infinity, 1 plus 1 by n whole to the power n equals to limit n tends to infinity 2 by 1 into 3 square by 2 square into 3 cube up to 1 plus n plus 1 by n whole to the power n divided by 1 by n equals to e. As we know, limit n tends to infinity 1 plus 1 by n whole to the power 1 by n equals to e. This is our formula. So friends, we go to the next theorem. Theorem number 4. Suppose Sn is a sequence of positive real numbers. Suppose Sn is sequence of positive real numbers such that limit n tends to infinity Sn plus 1 divided by Sn equals to L. Then limit n tends to infinity, nth root of Sn equals to L. Now I have to find out this value, n divided by n plus 1, n plus 2, n plus 1 whole to the power n. Let Bn equals to n to the power n divided by n plus 1 into n plus 2 dot 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 n plus n. Now Bn plus 1 is equal to n plus 1 whole to the power n plus 1 divided by n plus 1 n plus 2 dot 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 2n into 2n plus 1. It is this value is Bn plus 1. 2n plus 1 into 2n plus 2. So limit, now we have to see that limit n tends to infinity, Bn plus 1 divided by Bn equals to, you see that if I will divided this portion, so whatever I have got n plus 1 whole to the power n plus 1 divided by n to the power n, and you see that this portion and this portion is cut, means this portion and this portion will be cut. So this portion is 2n plus 1 into 2n plus 2. This is the rest portion, friends. Now I have to write in here limit n tends to infinity. Now you see that limit n tends to infinity 1 plus 1 by n whole to the power n, 1 plus 1 plus whole to the power n. Sorry, it is not 1 by n. I have written wrong. It is n whole to the power n into limit n tends to infinity. It can be written, represent this way, n plus 1 divided by so friends, here is some also mistake, that Pn plus 1 will be n plus 2 is starting point is n plus 2, n plus 3 up to this way it is started, and n plus 1 is remaining portion. So here you get n plus 1, so it is n plus 1 whole square. Yeah, now it is clear. It is n plus 1 whole square, 2n plus 1 into 2n plus 2 whole square equals to, this portion is the value is e, and this portion I can write limit n tends to infinity, 1 plus 1 by n whole square divided by 2 plus 1 by n into 2 plus 2 by n, and all the portion is 0, so whatever I get 4, 1 divided by 4, so the value is e by 4. Now friends, according to the application, whatever you see that this portion is limit n tends to infinity bn whole to the power 1 by n, and by the Cauchy's limit theorem, that it can be written limit n tends to infinity bn plus 1 divided by bn equals to e by 4. So my answer is e by 4. Now friends, this is the last theorem I have to solve, that is Cesaro's theorem. You see that if limit n tends to infinity Sn equals to n and limit n tends to infinity Tn equals to L dash, then limit n tends to infinity Sn into T1 into Sn minus 1 T2 and Sn minus 3 T3 S1 T1 is equal to LL dash n. So friends, this is the formula. Now for example, I have chosen one problem, limit n tends to infinity 1 by n, this is. So friends, you will see that Sn is equal to, in here 1 by 2 to the power n Sn, and you will see that Tn is equal to 1 by n. Now limit n tends to infinity Sn equals to 0 and limit n tends to infinity Tn equals to 0. So my value is 0 into 0 equals to 0. So limit, so my answer is 0. Thanks for watching, friends. I hope that I can clear this concept.